Morning, Chris. Morning, Jeff. Let's start the show. Hopefully we won't have technical surprises today. And let me try presenting slides. And I think I showed you this photo last time. I wanted to show it to the other class because they were the class on Monday that had the rainy day, and this was the end of Monday. But we got for a walk out. We've got to an awful lot of parks. Dora insists on a walk every morning. This morning it was cold, windy, wet, not very nice, just around the neighborhood. But in the afternoon or evening, we try to hit one of the parks in our neighborhood, and like the one that was with the rainbow, that was down at Regatta Point, which is a housing development, but there's a waterfront park to it, just a couple blocks away. In the other direction, there's Long Lake, which has got some nice new trails in it and a lovely spot. Not far away is the Dingle and Frog Pond, and a little bit further afield is York Rideau. There are an awful lot of parks around, and I think we're quite fortunate here in Halifax. Dartmouth, the same way. It's got an awful lot of nice parks. And my dogs over the years have insisted I get to know all of them. They're doing it for my health. So I finished marking the tests. I've got to go through and fix up a couple things with some students that had some problems, and I've got to manually adjust their grades. But I'll try to get that up and better feedback to you shortly on that. I've got to clean up some stuff in the grade book from old stuff. With respect to the assignments, many of the students that submitted in this section probably have had theirs graded. It's mainly section B that has got still quite a few to get graded. I've had my markers doing that using a marking key. I'll post that today, how they did the grading, and try to turn it around so you can get the feedback that they should have had. But first I need to look at it. The average grade on the assignment was like around 67%, which is way low. My average grade on an assignment should always be over 80%. And so I've got to find out, was there a problem that so many of you had? Or were the markers being too demanding and picky on you? And if they were, then we'll have to go back and revise some of the grades, because those grades are too low based upon what I've seen in past years with assignments. I'm not quite satisfied with that. So don't get bent out of shape when you see your grade until I've had a chance to review all that. So I'll probably give you some feedback at the beginning of the week. And I've got to get assignment 2 posted for you sometime today. You've got your test tomorrow. Starts anytime after 1 a.m. Halifax time, but you got to finish the test by 11 p.m. Halifax time. So that should give you a fair bit of flexibility as to when you schedule your activities. The questions this time will all be multiple choice. Then you won't get the delay that we've had because of I'm so slow in marking. And I think that will work fine. I did find, working through the word questions, is a similar problem to what we had last year with the short answer questions. Students with English as an additional language are more likely to misinterpret or misread a question, and that they have more difficulty expressing themselves in terms of an answer. I'm presuming this is a first-year course, where many of you are first-year students, and language proficiency will increase as you go through your program. But I don't want that to be a barrier in a first-year course. And multiple choice seem to address some of that language barrier issue. And I say that there's variation in how students interpret what I'm looking for in a question, and it may be that it isn't that they didn't know the answer or didn't know it as fully as I wanted it to be, but they thought that what they were giving me was sufficient. And so I'm not sure if it's working as well as I liked in terms of evaluating how well you know the material. So I'm rethinking that. Matthew, in terms of how many questions, I'm hoping to have 20 questions altogether. It may be 18 because it's divisible by 3, and I'd like a grade out of 6 for each test. So the tests will tend to be a multiple of 6. But it's more, I'd rather have fewer questions that were good quality and straightforward, no tricks, no confusion to it, than have more questions that may well be. I also don't want redundant ones. If I've asked you something once, I shouldn't be asking you it a second time, because those that know it then would get it twice, and those that didn't know the answer would be penalized twice. So there's an issue of fairness and balance. Making up a good test requires, at least I put in a lot of thought to it. I don't know about others. I don't use test banks like some people do and that sort of thing where they just randomly grab a bunch of questions. I try to do everything intentionally. Not always successful. I'm not saying I'm great at it necessarily, but I try my best there. How many minutes do you have? I'll still probably give you 45 minutes, which I think worked out all right for the first one. I can see in the word answers that it gave some students time to Google an answer and do a cut and paste in the short answer. That actually didn't help them because I asked a very specific one and they couldn't get exactly the same answer or same question and answer online. And so very often their cut and paste was close, but not as good, nearly as good as those that expressed their view in their own words. Um, and or did a search through the notes, the slides or the chapters to find an answer. So it seemed that people had enough time. Um, I don't want to give you way too much time like you have with your quizzes. Those ones I want you to be able to go back and look and because the focus is on encouraging you to read the course material. But with the test, I'd like you to have done that studying in advance. And generally, I'd say with the answers I got on the test one, I was very pleased with the quality of them. And I think they were better quality than I got when asking similar questions in a classroom. Because you did have a chance to search, true, but I didn't get the sense that most of them were cut and paste, and uh, they were by and large unique answers. The phrasing and that sort of thing. So there wasn't collaboration among students. There are some professors that are obsessed about cheating on these online tests. I didn't see. I saw some evidence that there might have been a little bit of collaboration, but not excessive. Um, and so it's better than putting in that excessive policing on this sort of thing. I've got to trust you. Anyway, let's get going. There's always some way to cheat. There's pointless trying to put up all the barriers, because there will be some that'll go on. So last time the last two classes, we focused on pivot tables, and these I'll hammer away over and over that I love them, but they're also really valuable. It's one of the the nicest features in Excel for looking at data, and I strongly encourage you to learn to be proficient with them. That you will have courses where you have to do different types of analysis and that sort of thing. In a pivot table, you may find is a very effective way of summarizing, presenting, even if it was marketing or financial statements, something like that, where you're just trying to show, total cost by product category or those types of things. And it could well be that you can take information out of some type of financial download that you've got from a firm, from some of their records, and put together a very effective analysis of things, particularly for a course like managerial accounting. Anyway, but remember that when summarizing things, we're summarizing them so that we can understand it better. To understand, you need to communicate. And it's like I've been saying with these short answer questions, that was communication challenges for some students. Communication underlies an awful lot of our misunderstandings or our understanding of things. And so some of the things to keep in mind, scale is critically important. If you're looking at frequencies, change them to percentages. That you have to understand percentage of what. Get to that one. Keep the tables as simple as you can. Don't have too many digits. Don't read too much into precision of things. They're distractions. You're looking at big patterns. You're looking at who's big, who's small. Don't include categories that aren't very important or very tiny, or merge them with others. Again, they become a distraction, and we get easily distracted by the small things and miss the big things. Sort your categories logically. If you've got an ordinal variable and you're going from very satisfied to very dissatisfied, make sure your categories follow that sequence. But other things you may want to sequence is, if I was looking at average salary by region, I may want to go, and I'll bring this up again later, from, if I was going left to right in a table, say, or top to bottom, it may go from east to west or west to east. So the average salary in British Columbia, then Alberta, then Saskatchewan, Manitoba, and so on all the way across, because there are regional trends, and those you see when looking at it that way. Whereas if I sort the data alphabetically and put Alberta at the beginning and Yukon or something at the end, it doesn't convey that same pattern that may exist that's due to geography. So it's like adding an extra variable in there. Sometimes if I was comparing sales by territory, I might be looking at highest to lowest. So where am I most successful and where am I least successful? Or product categories, which ones are most successful, which are least. And that becomes, again, a useful piece of doing that type of sort as well within the categories. A lot of people find, most people find, charts, if they're well done, more effective than tables, because the charts emphasize pattern, whereas tables emphasize detail. They emphasize precision. And if you're first looking for pattern, look at a chart. And then if you want to drill down to it, you look into the table. Both are useful, but understand what their roles are. Those percentages, most of the time we're looking at percentage within various groups. So if I'm looking at, and last day we ended, I think, with looking at program and gender and how many students we had. And so I might be interested in what's the percentage of females within the business program. Or I might be looking at the percentage of business students that are female. Watch your language. What's the percentage reflect? Is it that females are more or less likely to study business, or that they're more, or among business students, it's more or less likely to see females in that class? I don't know. But the percentage, generally it's a percentage of something. And so you have to be explicit. In labeling a chart, you've got to be that. In a table, you've got to be clear in stating that. It's not necessarily obvious to the reader, and they may misinterpret it. If you're comparing variables, comparing two at once is great. We're quite good at looking for those patterns, but very few people are very good at looking at three variables all at the same time. And getting to four variables is next to impossible to do. It gets very, very confusing very quickly, unless the variables have very few values, if there's a small number of categories. But we can't process large pieces of information at once. Even a table that's got, that I'm looking at the year of study and what program you're in. So 4 different years of study, 3 different programs, that's 12 different entries. if I add in gender, now I'm up to 24 different entries that I'm looking at. It's an overwhelming amount of information, and these are variables with very, very few categories. Also, when you're splitting it up, your samples get smaller, and so the precision of the numbers that you've got gets worse and worse as you split them up. So although it's useful to go and explore those patterns, we have to be very, very cautious. So today, I'm going to sort of take that caution about interpreting tables or charts, but I'll be using tables as my example. A further caution in there, and it sort of relates to the discussion question that we had for this week, which was about the pattern that was observed that students that take a full course load have a shorter time to complete their degree. Not rocket science, I guess, but that was then viewed as, okay, let's encourage or force or pressure students to take more courses so they can finish faster without looking to see, are there other variables that are in this mix here? And the other thing we're going to do is, when we're doing comparisons, we did comparisons of 3 histograms, and that was very confusing. What if you had to compare more than that, but you wanted that level of detail, not just averages? How do you do it? So first, let's look at the first issue of Simpson's paradox. When we started out doing comparisons, even before pivot tables, we had started to notice we were looking at the salary data and looking at averages, and discovered that males and females had different average salary expectations. And a year ago, when we first started looking at this data, and I looked at it for the first time in class, everything was live. It wasn't all scripted like it is for this online class. And, oh, this is strange. So we asked, well, can we explain what the gender difference is? This isn't outright discrimination in the workplace because they haven't started work yet, but maybe they expect to have gender discrimination in the workplace, and that's what we're seeing here, is that there's already an expectation before they go out looking for jobs. But then ask, is there an alternate explanation? And the students didn't necessarily know this. I was very familiar with our enrollment patterns and knew that females were more likely to enroll in arts than any other program. And when you look at art students, it's predominantly female. Whereas something like business, the student mix is more evenly split between male and female. So, and there's good data to show that arts graduates, at least in the first 5 years or so of employment after graduation, tend to earn less than business graduates. So if we've got a large group of females in arts, then they're going to come out with lower salaries than if we have a large number of men that are in business coming out with higher salaries. So maybe there is what we call a lurking variable, a hidden one that we are not looking at, that explains everything. Maybe it's program that explains the difference in the salaries that we saw between males and females. But then when we looked at it, we discovered we were wrong. No, among art students, men expect to earn more, and among business students, again, men expect to earn more. It wasn't a program difference. And that was a little bit disquieting. But suppose that wasn't the explanation, and or suppose program was the explanation, but people jumped to the conclusion early that it was a gender difference and not a program difference. So this is a problem that we get with aggregated data. All data that we've got is aggregated. By that I mean the females were made up of students in different programs, different year of study, many different characteristics among them. They aren't all the same. And the men weren't all the same. That we've got a few international students in this class. I bet you hate being called international students because you're not all the same by any means. Chinese students are nothing like Nigerian students, and Nigerian students aren't like Bahamian students. And then even that among Chinese students, they're not all the same. There's huge differences among people, and it's inappropriate at times for us to lump them all together, but at times we have to cluster to be able to do some types of analyses. But it's a very gross level. But in that aggregation, we hide things. And it may be that we need to split down and look for another variable within that might explain the differences that we're seeing, and that these differences may be due to a lurking variable. So I'm going to show you a couple of examples on this about trying to find this alternate variable. So the first one is one, since we were talking about averages, I'll try to illustrate. And this is just contrived data. But suppose we have two factories, A and B. They both produce about the same amount of units each month, 2,000, 2,500 units. But when we looked at the cost data, we found that plant A, the average cost was $5, plant B was $6. And you might draw the conclusion that plant B is less efficient. Its costs are about 20% higher than they are at plant A. That's at that high level. That's like comparing genders at the high level. Without asking you, well, are plant A and plant B the same? Do they do the same thing? They produce this similar number of units. Do they do the same type of work? So you go down further and you said, yeah, they do. They produce two products, P and Q. And so they're the same. Do they? No. When we look at it, we see that plant B specializes in making product P, and plant A seems to specialize in producing product A. They also produce some of the other, but almost all of plant B's output is product P. Almost all of plant A's product is product Q. And these two products are quite different. Product P is more expensive generally to make than product Q is. So maybe the explanation for A and B and their efficiencies, their average cost, is just a different product mix. And interestingly, if you drill down into the product mix, you get the reverse conclusion. You find that actually plant B is more efficient at producing both products. So not only is the difference that we're seeing due to the products that they're making, but I am reversing my statement about who is more efficient, who is more cost effective. It's actually plant B is more cost effective than plant A. This type of reversing of things is known as Simpson's paradox, that what looks to be that A is better than B in one setting, when you drill into the data, you may find that you come to the opposite conclusion. B is better than A. And how does that happen? And generally it's because we've aggregated our data, and especially that our data is unbalanced. And you see in that table, there are 4 quadrants to it. And I don't have roughly 1,000 units in each quadrant. I've got a whole bunch for plant B producing product P, the stuff that was sitting up here, this guy. And I've got a large chunk down here of plant A producing product Q, 1,800 units. And because of that unbalancing thing, that's what really leads to that reversal of things. So if you've got other variables at play here and particularly if you have unbalanced data, it can easily lead to distorted conclusions when you aggregate things. And as I said, it's known as Simpson's paradox because a fellow named Simpson wrote a paper about this. I think many other people were aware of it, but it just hadn't been put in sort of the academic media about it. Here's one that I found personally interesting because I can vaguely remember the incident. I was a student in the early 1970s, so a long time ago, and The 1960s and 70s were an interesting time in North America, especially. That was when all the baby boomers were hitting university, but it was a big change. There was the Vietnam War in the U.S., the civil rights movement in the 1960s, especially, created an awful lot of activity, much more in the US than in Canada, but we were actively watching all of those sorts of things. But there was also what was known at that time as the women's liberation movement. Um, Recognition that not only did we have racial inequality everywhere, but we also had serious gender inequality everywhere. And students at that time at universities, there's huge growth in universities, and this very different population, both in terms of the music we listen to and a whole bunch of other social change. Um, but on university campuses, it was very common to have huge demonstrations, to have campuses shut down, to have riots on some campuses, um, takeovers of parts of the campus, that sort of thing, occupation of the president's house, or that type of thing. And a lot of it had to do with giving the voice to students, but a lot of it had to do with both the racial inequality and gender inequality. And so data got publicized at in California, at the University of California, Berkeley campus, which it's a world-class university, and their graduate school is outstanding. Um, it's a very, very large graduate school. They'd get 12, 13, 14,000 applicants per year. Uh, and what was reported was that the admission rate for men was much higher than that for women, and that women were not getting access to graduate studies in the same fashion that men were, and that women were being discriminated against. That caused some real consternation on the Berkeley campus, at least among the administration. They didn't see themselves. They saw themselves as a very progressive campus. It's a very turbulent one in the 60s and 70s. It was very much at the center of the sexual and drug um, uh, revolution culture, music culture of the time. And the uh, I think they saw themselves as being much more liberal and progressive. When they looked in at the department level, that's when they saw what was happening. And here's examples of that. Departments A and B, primarily males applied to it, and the admission rates were very high for both men and women. But it was, so we get this large number of men that are becoming admitted relative to women, just because it was programs probably like engineering, that computing science and that type of thing at the time, that were uh, very, very male dominated programs at the undergraduate level as well as graduate level. Uh, Women at the time, and there had been significant growth in women pursuing post secondary, uh, tended to be much more clustered in the humanities and social sciences. And with those programs, they had a lot of men applying to them, but the acceptance rates were very low relative to programs A and B. And I suspect A and B were, as I said, were science engineering oriented ones, where there was a lot of money to support graduate studies. And so they took in a lot of students and funded them. Whereas in the humanities and social sciences, there was not a lot of funding that was coming through from outside and governments and the like. And so they could take in very few students. So women were applying to very competitive programs like Program E, say, that men were not applying to. And that men were applying to very uncompetitive programs, easy programs to get into, that women were not applying to. So the acceptance rates were very similar between the two. And but this created quite a lot of controversy. What's my point here? It's when you're looking for a pattern, and that's what you're out looking for. So you get excited when you find a pattern. Before you jump to a conclusion about that, ask yourself, why is that pattern happening? Why am I seeing gender differences here? That is it gender discrimination, or is there some other underlying cause of this? That start looking at other variables, other differences between the groups you're comparing. That are they basically the same sort of groups? They have the same opportunities, or are there other explanations for it? And um, and there may be that, but at the same time, don't be overly critical. There's some that jump to dismiss a pattern very quickly because they've got some explanation in their head as to why it's happening. Use the data, drill into the data to see if the data provides an alternate explanation or not. Don't just come up with your ideas. You may it's come up with the ideas, yes, but you should be confirming them one way or another with data. And why I emphasize this is because human nature, um, we're biased. We're not rational. If we have a belief that we believe that some type of discrimination is taking place and we see some data supporting it, then we say, yeah, see, we're being discriminated against. And you'll jump to the conclusion without looking deeper. On the other hand, if the data doesn't support you, and that it's the pattern isn't what you expected to see, or there was no pattern, or something of that nature, that very often people will find reasons to dismiss the research evidence because it doesn't fit their beliefs. Everybody does that. Every manager does that. That politicians do that. Special interest groups do that. Anybody that has some preset ideas, a path they want to go down, and generally everybody has some sort of thoughts in that. They're looking for data that supports them, and they have a blind spot for data that doesn't support them. If you've got the data, go and look and see what the story is that the data is telling you. And there's probably still more story to it than the data actually gives you, but think through that. And that's sort of what I was trying to get at in the discussion question about this belief that, well, it's true. Students that take a full course load do graduate sooner, more graduate on time. Yeah, confirmation bias, very much. Yes, I don't have a psych background, but this is what we're getting into, okay? How these sorts of things, that's exactly right. Um, Jeff, good point. Um, that I just know numbers, and I know the many times I've been wrong in conclusions. Um, but the we've got to think about this. That I'm sure you wouldn't think that doing data analysis is an exercise in psychology. But psychology comes into this, communication comes into this, and don't lose sight of them. We're not objective and rational in so many different ways. So that's my first point for today. My second point, though, is comparing many groups and trying to preserve some detail, not squishing down to averages, but giving some of the richness that's in here. And with the salary data, there was certain richness here of those patterns that were there. It would be nice to keep. But this chart, no, it's not good. I wouldn't use it. I try to avoid using it. It's too busy. In my mind, it's got too much detail. What do I mean too much detail? Do I need to know all the categories? Probably not. What is the detail I want? I want to know what's typical, average, typical. I don't know what the word should be. I don't want to use average in the sense of that X bar average, but what does the typical sort of student expect to earn? And it looks like it's somewhat lower in arts and a little bit higher in business and a little bit higher in science. And I might also want to know, well, among art students, are many of them expecting to earn a very low salary compared to business and science students? And yeah, that's exactly what it's telling me. There's a large bunch of art students that expect to have very low incomes. What about really high incomes? Well, there's a bunch of science students that expect very high incomes. So there's more to the story than just the typical one. It's also the low income people and the high income people that are there, and where are they located? Who are the high and the low income? So at the very least, we want 3 pieces of detail here: middle, high, low. And we also may want to know about very high and very low. So maybe 5 number summary. But if I gave you 5 numbers, so I gave you the numbers for of these, whatever very high, very low, low, high, middle represent for arts, business, science. For those 3 programs, I got 15 numbers to compare. For many of us, that's going to be too much. I can't remember a grocery list with more than 3 items on the list. I've got to have it all written down. I can't keep it in my head. We can't process large numbers of things unless they're organized in some fashion. But if I've got a chart, I can have a chart that's got a lot of information in it, but it takes away some of that granular detail that isn't important. So that's what I'm going to use. And I'm going to go back 50 years to look at very, very simple methods. I like to talk a little bit about the history of this because it was my history. John Tukey, very famous mathematician, statistician. I think he worked for Bell Labs, which in the 1970s was the best place you could possibly work if you were doing research outside a university. That computers were huge. That if you can imagine a small two-story house or a bungalow with a basement, so you've got 2 levels, and you've probably got a building that's 20 by 30 feet or 25 by 35 feet, something like that. Good size space. That many of you maybe grew up in homes that size. That's how big a computer room was, because the machines were huge and we had tons of air conditioning equipment in there because they got really, really, really hot. They were very expensive and not readily accessible. The first computer I worked on, I could access remotely. I was living in Montreal. My high school got a terminal to a computer. It was a very unique business deal. Where was the computer? It was in Chicago. That we, no one had their own. And we were linked by telephone. Hand calculators, they came out in the 1970s, very expensive, hundreds and hundreds of dollars, and they didn't do half of what a calculator that you buy at the dollar store does today. They weren't accessible. When I was an undergraduate at UNB, we would go to the calculator lab to access calculators because none of us could afford to buy them. So Tukey was looking at very manual methods. He was working for a high-tech organization, but still that the data sets, a lot of the ones we worked with were relatively small. Bell Labs, they had more technical engineering data and they had bigger data sets. But still, for the most part, you didn't work with data sets more than several hundred, maybe 1,000 observations because it was just too much work. It was manual. And you can imagine trying to work out an average. Try working out a standard deviation, finding a square root. You did that with a slide rule. If you don't know what that is, you're lucky. What he did was come up with really, really simple things that focused on picking out. These were manual tools. So here's what he did. He'd start out, if I took a data set with 40 observations, and 40 is even big for doing manually. I'd likely make mistakes putting it into a calculator. Sort the data smallest to largest, because that'll give you right away an idea of what's really small, what's really big. And if you look in the middle, that's the middle. That's the nice thing about sorted data. The median is where are you in the middle of your data set. So if I got 40, that means 20 or below, 20 or above. So the median is between 70 and 70. 70 is the median. Half my data is smaller, half is larger. So I can do that, no calculator, no work. Sorting it doesn't take that long to do. Even with big sets, I can do it. Then what about finding low and high? Okay, so take the first half of the data, the numbers 15 up to 70, and split them in half. Where is the middle of them? The middle is between 60 and 62. Call it 61. if you take half and cut that in half, you're cutting things into quarters. So 61 is the first quartile. And do the same with the second half. It's going to be between 78 and 78. It's my third quartile. So I'm going to start out by saying that's my value that I'm saying is on the low end and on the high end. The middle half of my data set, the middle 50% of my values are between 61 and 78. And so that's the middle section. That's probably my most important group. And the low end of the middle is 61. The high end of the middle is 78. Now, what would I call very low? What would I call very high? Well, what I could do is go and try to figure out, I've got some that may be outliers. Is 95 an outlier? Is 15 an outlier? I don't know. Outlier relative to what? So you may take the middle group and say, okay, this is the middle group. Are they a very diverse group, the people in the middle? And well, difference between 78 and 61 is 17. So 17 points splits the first and third quartile. So the middle section is only 17 points wide. So how far should I go down below that or above that to consider something to be really high or really low? And it turns out 1.5 times that distance is called the Iqr Interquartile Range. It's a range between two quartiles. 1.5 times it ends up being a fairly big step in that it's very unusual to get values below 1.5 quartiles below the first quartile and 1.5 above the third quartile. So 1.5 of times 17, that's 25.5. Go 25.5 units below 61 and you get 35.5. That's up here. So if I'm above that fence, he called it, then you're okay. If you're below the fence, you're an outlier. And on the top end, I'll build a fence as well. And if I'm above it, I'm an outlier. And they gave names. They called them lower adjacents. And you can guess with the lower end, and upper adjacents with the upper end. So this will be by definition of being very low without being an outlier. I don't want to focus on outliers when I'm defining low and high and very low and very high. Not on the extremes, but on ones that I shouldn't be surprised to see. And so I can have a fence on the top end as well. And I'll have my upper adjacent. Okay. So I end up with 5 numbers here. And let's just take them and put them into a picture. So here's a picture. Ignore my orange lines here. That was from my last class, and I put that on. I didn't realize it stayed on the slides. The middle box goes from 61 to 78. It's a big box to draw your attention to the middle 50%. This is the group that you should be generally thinking of when you're talking about the typical student, in this case, writing this assignment. And it turns out that that middle group is split fairly evenly right down the center. That this is the median. Now, if the median was over here to the right, I'd say that, they're skewed in one direction versus the other. But so sometimes it's important to see where is that middle line. That is the top half of the middle bunched together, or is the top half spread apart, or is it evenly spread? These things are called the whiskers. This goes from my third quartile up to my upper adjacent. And so this goes from what I thought was high up to very high. And roughly a quarter of my data is here, a quarter is here, a quarter is here, and a quarter is spread out over this stretch. And this line may look to be similar in length to this box, but remember, here's 25% over this long stretch, another 25 over this short stretch, 25 and this. So these ones are very concentrated, and 25% spread over this big chunk here. If I had had a histogram for this data, it might look like this, where it's probably they got more and more towards the middle. Then I've got a big bunch in the middle, and then I've got a quarter that are spread out over here. That may be roughly the pattern it was. And then I had two that didn't fit. These are outliers. And so these things are useful for me in terms of my eye being drawn first to here, then to the whiskers, and then these I didn't forget. I should probably investigate why are they so low, what went wrong. But it gives me the whole pattern. And I can do this then for for comparing several groups. I could compare several of these little diagrams. And that's what we're going to do in just a minute. So why are we using them though? This is very archaic. It's a Stone Age technology in a sense. We've got all kinds of amazing tools today, don't we? Why should we be using this, which is so crude? Um, and I must say, over the years, as being someone that was originally trained as a statistician, I was quite fascinated by this. I learned about it around the time that Tukey published his book. I was in graduate school, and one of my professors was a student of John Tukey, one of his early doctoral students. And she introduced me to this sort of thing. Gee, this is very neat. It's completely different from all the theory and the rich mathematics and that sort of thing that we have in other courses. But it sort of makes sense that uh, but for the most part, I didn't see it appearing in much in books or publications for many years afterwards. Uh, I used it myself, but um, I can't think of any other colleagues that paid any attention to it. But in the last 20 years, computing scientists have picked it up and used it in data mining because they wanted simple graphical tools to search for patterns. That's what they were looking for. And it's in just in the last 5 years, I think the second to last upgrade to Excel, that it became a feature within Excel. And so that's what we're going to do now with it. Let me flip over to our data that we're using last day in Excel. And I want to go and look at the salary data. So this is the salary data. Okay. So I'd like to go and work with this column of numbers here. Okay. Well, I can actually go up and I guess click salary, the whole column. Okay. And if you go over here to insert over in the left, it allows me to have charts, and there are different sorts here. Click on recommended charts. And it suggests various sorts of things. It can actually do histograms. That's been added in their chart thing, but I don't want to go into that one. None of these ones are the ones I want. Go up to all charts and go down here to box and whisker. Okay, and click OK. And it throws it there in the middle. Way I can't see my data now. But here's my chart, and it's got a box. It plots the chart, whereas I plotted it horizontally. It plots it vertically, which is probably a better way of doing it. I just do it horizontally out of old habits. That was the way I was taught almost 50 years ago. That the box here, this is where most of the students said their salaries were. Very low, I guess, was down around zero. Very high was around $100,000. And then I've got these outliers. There's what, 1, 2, 3, 4, 5, 6, 7, 8. There's at least 8. There may be multiple ones on top of each other here. But these outliers are using almost all my real estate. And I've got over 700 that are hidden down here, and I'm not seeing detail on. So the first thing I may want to do with my chart is, so that I can actually see it to scale, click on it and right click I can format data series. We did that with histograms before in formatting things. And it gives me various options. One is how quartiles are calculated. This is stupid. It won't change my chart, whichever one I pick, unless I've got a super tiny sample. That this one is showing a marker for the mean instead of a line for it. I'll explain when we get this bigger. It says show inner points. That would show all 750 data points that are down in here. I don't want that. That's too much detail. But it's showing outlier points. Uncheck that. There we go. So it takes those out. Now I can see that very high is $90,000. And I think we were before trying to exclude ones above 120. That this suggests you should probably be excluding ones above 90. It's a little bit hard to see, and I'm going to change, because it's using blue for everything in different shades. I'm going to change colors here. When I'm in, here's design, and I'm going to use it to reformat this, but I'm going to go over to format. And in format, I can format other things here. I could change the fill. Let's see if I can, oh, hey, I can use different colors. Let's change the fill to yellow. And then the outline, let me make that black, but I'm going to make it bigger. I'm going to give it more weight so it stands out. There we go. Boom. Okay. So here I'm seeing this is the middle 50%. They're between about $35,000 and $60,000. There seems to be half of them are between the 50 and 60, and half of them are between 50 and 35. So it's a little bit skewed towards the top end. Here's the top 50% or top 25%. So here's 25% are in this big group. Notice 25% are in this little group. Okay? So that I got a lot concentrated here compared to here. And again, compared to this group, they seem to be very spread out. I'm not getting into a lot of detail as to how they're spread among these different groups, but this is given, I've split my data into 4 groups and my chart showing the 4 groups. That X that you see there, that's the mean, and this line is the median. So the median is a little bit lower than the mean. If you recall, the mean was around 53,000. The median is at 50,000. So that's a very nice, simple diagram. By itself, a histogram probably would have done better, okay? But if I want to do comparisons now, let me go back to design, and I'm going to go to select data. Let me just get this out of the way here. I don't want it anymore. So in here, I can go and edit, okay? So this is showing salary, but on the horizontal axis, there's nothing. Let me click edit, and it asks for, what do I want on the horizontal? I'd like to compare programs. So I'm going to go over here and click on programs. This is going to be fussy. So whereas a lot of the other analyses we've done, I picked the label up here, program, don't. Just start and pick this guy and on downwards. The bottom row is going to be 812. So I'm not going to scroll all the way down or I'll lose my picture. Okay. So I'm taking all of those values. So what does it do? It went and it took arts, business, science, arts, business, science. And if I scroll down here, I'd see all of the other ones that are listed here. So it's not just saying that the values are arts or business or science. It's taking a list of all of those. But it's going to summarize using that. But my chart's over here. Oh dear, what did it do to me? Did something wrong? It didn't catch it. Let's go back. Hold on. Something's wrong here. It only took the first, oh, it didn't take the, excuse me, took the first 5. It didn't take all 812. Here we go. That's better. And click OK. I don't know if you could see that it had already updated the chart for me. There we go. Now I've got, I'm not sure about this guy here, what that is. I've got not applicable and other I want to get rid of. Engineering is a small group. We've got an outlier now. It just in engineering, most of them are concentrated here, and this one is so far out, it's classifying it an outlier for that group. Let me just get rid of the ones I don't want. Whereas last day we had a pivot table and a pivot chart. If I wanted to change things in my pivot chart, I went to the table and I moved variables around or I changed things in it. This one, I don't have that table to edit, and that makes it a little more awkward for me in doing formatting. So I'm going to go back here and I'm going to click on this and I'm going to just take out engineering, other, not applicable. Okay, let me go back here. Whoops. It's still got this one here. I'm not sure what's causing that. No, I don't want it. But from this, you should be able to see, let me just scroll down a little bit, make this, whoops, bigger. You can see that the average for arts is less than that for business and less for that for science. We'd seen that before. And clearly the medians are, well, the median in terms of business and science are very similar. Okay? And it's the science data is skewed in a different fashion from the business data. Where are the differences? Look at the boxes here. So the middle group for arts is significantly lower than that for the middle group for business and the middle group for science. How they're lower? Well, if I look at arts and business, I see that in business, that bottom group is much further up. Okay, that bottom, and this group as well, is they're not as spread out. They're more, and when I look between business and science, I see that science, this lower quarter is similar to that lower quarter in business, but those that expect to have a salary that's somewhat above the middle but not excessive is much more diverse in science than it is in business. These whiskers, I'm not sure if they're telling me that much. We still have on the very high and the very low, they're very similar across the three programs. It's the people in the middle that are very different in the three programs. The middle group is where we're seeing this activity take place. So this is sort of interesting in terms of doing it. And so if I wanted to do comparisons across many, 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 many groups, I can visually look at this quite quickly and see who's up, who's down. I can still see the averages like I would if I had a column chart or something like that. But this is giving me so much more detail around that average that I didn't see previously. And that may be very, very important information. And it would also, like we saw with engineering, if there were outliers within each of these, so these are different in terms of these things and that there are these outliers, it starts to highlight those types of things as well. That, let me double check to make sure I've not lost what I'm supposed to be doing here and check my slides. So I did all of those sorts of things and bringing it up from Excel. And this was the chart that I got out of Excel. And, oh, okay. In the slides, I pulled in program first and I got that mess. But I can't make comparisons with that at all. Those outliers made it impossible to do comparisons. So got rid of the outliers and then I got rid of the programs that weren't important. And in the bottom right there, you see the chart that I've got right now. So there are a lot of things that we can do in that when doing it, but let me go and show you something that gets busier and it gets messier. and I got to move quickly so I don't run out of time here. Let me go up here and select data. I'm going to do a couple of things here. I'm going to edit here. Oh, second. I should go back and remember I put a filter on program. Take it off. Okay. Always forget to do that. Exploring my data, I like to have filters, but they cause problems too. So I'm going to go up, I'm going to select data, and instead of taking program, I'm going to look to see those people that expect to earn a really high salary. Are they actually concerned about that? And so I'm going to click on this column instead. And let me go on so I don't have to scroll all the way down, put in 812. And so they are not concerned at all, somewhat concerned, not concerned, not sure, and so on down the list. Okay. And is this going to work, or is it going to, no, excuse me. See, it stopped there. Oops. Oh, okay, I'll do it the hard way. So the difference here is that program was a nominal variable. This one's an ordinal one because it goes in different rankings. And see, now I lose my picture way up at the top here. And it's one of the problems I find with charts in Excel when I move things around is that it I have to scroll back and try to find where the chart is. So we've got not concerned at all, somewhat concerned, not sure, neutral, somewhat unconcerned, very concerned, not applicable. Some of these things are annoying. Whoops, here it is. I don't want not sure and not applicable. Okay, so it fixes my chart right away. And we see that for most of them, that these middle sorts of people have similar levels of concern, or the level of concern for each of these all seem to have, when they're at the lower level, not really high salary expectations, or they're sort of middle of the pack ones. The ones that are very concerned tend to be people that have very high salary expectations. Look, they're way up here. So that's interesting to look at, is that the those that are very concerned because I'm not sure if they expect to earn a lot of money or they want to earn a lot of money. That their desired salary is very high. And so, yeah, they'd be very concerned because it may be hard to achieve that. All right, that's fine. Let me take that filter off again, just in case, and see what happens. I select my data and I look at any job. So I'm going to change from, oops, I'm going to use these guys here, that column H. And I'm going to scroll all the way down. Oops. How did I do that? What did it do to me? Going over to A. Oh. Pay attention. All right. There I go. Okay. So I'm in column H from 2 to 12. That sounds right. And so they've got a whole bunch of different things. And now I've got to scroll way back up and move over here a bit. I get this thing. Oh, I've got these strange things in here too that I don't want. Let's get rid of the not applicable and not sure. I don't know what that blank guy is over there. So I'm getting rid of the ones I don't want. Okay, good. So I look and see what's the pattern look like here. They all look to be about the same. All right. Look at the horizontal axis here. Not concerned at all, very concerned, somewhat concerned, neutral, somewhat unconcerned. This is an ordinal variable. Um, they that it's with an ordinal variable, we'd want this sorted, and we did that with pivot tables and pivot charts. We sorted things from not concerned at all up to very concerned. But I don't have a table anymore to go and do that sorting. How do I move things? It won't let me go and move things. I can't slide them across. I can't, it just moves the chart around. Took me ages to figure this out. Didn't find it in any manual or that sort of thing on Excel as to how to do this type of stuff. And it was only by accident I discovered what the reason was. And let me slide this down a little bit. Oops, excuse me. And show you what happened. Whoops, I got to go a little bit further up here. When we looked at salary and looked at the data, the first value was not concerned, then somewhat unconcerned, and then not concerned again. Then the next value, different value, was neutral. Then it was somewhat concerned. And much later on, it says very concerned. So you'll see that the first value that occurred is not concerned at all. The second one that appeared was somewhat unconcerned. The third one that appeared was neutral. And the fourth one that appeared was somewhat concerned. If we look at this one, the first one that appeared for any job is not concerned at all. And the second one that appeared was very concerned. And the third one that appeared was somewhat concerned, and then neutral, and then somewhat unconcerned. That's the sequence my chart's in, is that sequence of where these things appear. Like, how do I fix that? Well, we can fix it by cheating. Not concerned at all, I want first. Then I want somewhat unconcerned. Cut it. Go up here. Do an insert, oops. Insert paste row. And then I want neutral. Cut it. And I'm going to put it here. Insert paste row. And somewhat concerned. Got it. Where am I cut? Oh, there we are. Up here. Okay. So do I have it in the right order? Not concerned, somewhat unconcerned, neutral, somewhat concerned, very concerned. What happened to my chart? Oh, sorry, scroll down here. Ta-da. It follows the right sequence now. So you've got to do bizarre tricks. And sometimes they're undocumented things and the like. This one, as I said, I haven't seen it elsewhere. I discovered it purely by accident. I was very frustrated trying to figure out why I got a nice chart the first time and an awful chart the second time. But we can work through these things and get a sense of what are the different patterns that we've got within this. Some of these things are strange. I was just noticing my very concerned, look where the X is for the average. This data must be really skewed with a whole bunch up here to pull the average way up there when the average is the same as the third quartile. That's unusual. That one's a little strange there too. But these charts can be very, very effective in doing comparisons across many groups concurrently. And and looking beyond just a simple average and seeing big patterns and that sort of thing. And so even when I look at these averages that waver up and down, looking across here, that middle chunk seems to be relatively stable across. And so it may give me a better sense than just looking at averages. go back to my slides here because I think I am pretty much at the end. So this is my one here, and that was based upon being concerned about getting the salary you want. So the highlights for today are the two takeaways for today. There are only two. One of them, watch out, that's that one more caution. I gave you previous cautions with pivot tables, pivot charts about doing comparisons and presentation. That you're looking for patterns. You get excited when you find one or when you don't find one, if that's what you're looking for. But all data is aggregated. It's very easy to jump to conclusions that are incorrect. So when you find something or you don't find something, if there's something you want to comment on, go and look to just double check to make sure that there isn't one of your other variables there that might explain what the differences are. That you can only work with the data you've got. If it's a variable that you didn't collect data on, of course you can't drill into that, but maybe that will advise you in future. You may want to do some additional checking to drill down and see, why is this happening? Because when you see a difference, it doesn't tell you why. You come up with the why. Your data may give you insights about the why, but data doesn't automatically tell you why. You need the theory behind that. Be cautious about that. And the other is, when you're doing comparisons, sometimes look beyond just looking at averages, because the averages don't, they just reflect some measure of the middle and not the diversity of the groups that you're comparing. And the groups may be very, very diverse from each other, so that just looking at the middle doesn't tell you nearly enough. To do that, though, and not be overwhelmed with information, you need to have some simple, I call it a stickman type presentation. A stickman, in terms of drawing a person, is just, a round ball and these straight arms and legs, and that's okay. But to demonstrate certain things, they can be very, very effective in their simplicity. And they highlight the main features you want to show. That may apply as well to different types of graphs. And these box and whisker charts end up being ones that are very useful for giving you much richer detail. Not everything, it's not perfect, but it's enough detail without being overwhelming, because most other types of presentation tools will end up overwhelming you. So there's a lot there. Sorry, Jeff, I didn't answer in terms of your industry standards. But yes, different job sectors have different things. And so if you're expecting out of a certain program to a certain job sector, like engineering, will pay very well. Computing science will pay very well. Versus humanities, social sciences, and sciences tend to go into general type business occupations, and it isn't generally as well. What tests you're going to be tested tomorrow? Your tests are always on the previous two chapters that we've gone through. So chapters 3 and 4. So go and review quiz 3, quiz 4. They're the best indicators of what your test is. Test 3 will be chapters 5 and 6, and it'll always be in that fashion. I won't, unless I give you a lot of warning, I won't ask you questions on chapters we've already tested. So we're going to keep it fairly compact and predictable. And yes, all multiple choice. So it should look like, if you could imagine another quiz 3, quiz 4 pasted together, that's the sort of thing you're going to get. Okay. And one more. Oh, okay. Thank you. Thank you. Anyway, what's coming up next? We're getting now finally to approach modeling. We've done data prep and that sort of thing, and we've been doing some data exploration to help us think about what type of model, what do we want to do with this? And even some of the stuff in pivot tables, some people would say that is enough, that's the model. A lot of our models are just descriptive, and pivot tables are enough to do a descriptive model, like in profiling. But if we want to get into prediction models, that's where we're headed next. And we'll look at value estimation. And so we'll be looking again at exploring data, but with the thought that the output of our exploration is going to be to build a model, and in particular, a value estimation model. And this will lead us into chapters 6 and 7, which are focused on that specific sort of topic. So we've got some extent more complicated, but you're going to find that I'm going to go back to pictures again in terms of how to build a model. It just doesn't happen. We can construct it in pieces and make it more and more complicated. But in terms of trying to figure out how to enhance it or improve it, pictures end up being helpful again in getting back to some of the stuff that we've already used. Some of the tools keep carrying forward as we go. Anyway, that's it for today. Good luck tomorrow. I hope I don't surprise you with anything, and I'm expecting you all to do extremely well. I've got to find out why you didn't do extremely well on assignment 1, and the I will be trying to get assignment 2 posted today. It'll be a lot on pivot tables and stuff. So you have a good weekend. Hopefully the weather improves. Have a happy Thanksgiving. Uh, enjoy your turkey. Don't get COVID. Take care. Bye-bye. All right. And where is my recording taking place?